Hey everyone, welcome back. So today we're going to be solving another question. It's called as candy, right? It's a hard level question, right? And I'll be solving it in Java, but ideally the language doesn't matter because the the concept behind it is still going to be the same, right? Yeah. So let's get started. Just one thing. As you can see, uh, I don't have any submissions as such, right? Because I'm not solved this problem, right? I wanted to make a video on it solving the problem because right, if I'm stuck at a point, right, and then I figure out the solution for that, and let's say you are also stuck at the same point, right, it'll be easier for you to get over it and you'll understand where you're going wrong, right? That's the whole idea. But I do know the idea that I'm gonna go with, right? I do know the approach that I'm gonna go with. But yeah, let's try to figure out. Okay. The question says that there are n children standing in a line, right? Each children is assigned with the rating value given in the integer array ratings, right? So you have a array called as ratings, right? And each of these arrays is each of the element in the array is nothing but the rating of the ith child, right? So the first child has 1, the second child 0, the third child is 2, right? You're given these candies to children subjected to the following requirements. Okay, each child must have only one candy, right? Okay, must have at least one candy, not only one. Must have at least one candy, right? And then children with a higher rating gets more candies than their neighbors. Okay, maybe this is a bit confusing to understand the problem, because the description is too bad. It's looks like it's written by someone who's not technical, but I'll make it easier. What the question says is that when you're given an array, right? You're given an array called as ratings, right? You have a ratings array, right? And then you have random elements in it, which represents the rating of the ith child, right? So the first child has 1, and let's say the fifth second child has 5, the third child has 2, and then the fourth child has 3, and the fifth child has 0, right? So ideally this is it's zero based indexing, but when you're talking about real life entities, we convert it to first one base indexing, right? That would make more sense. You can't say zero child, right? Yeah. So this is the ratings array, right? Given you a ratings array, you need to figure out the minimum number of candies to distribute to all of the children's, right? given that Given that there are two constraints, right? The first constraint is all children must have at least one candy. At least one candy, right? So no child, even with the rating 0, no child can go with 0 candies, right? All of them have to get one candies. And the second thing is that excuse me. Second thing is that the neighbors should have more candies than sorry uh ith ith child should have more candies than its neighbors if it's greater than them. If it's greater than them, right? What is greater? The rating, right? So so let's look into the example. What do you mean by neighbors, right? Is it the one that is to the right, or is it the one that is to the left? They haven't told you what it is, right? So what does neighbors ideally mean, right? Neighbors ideally mean on the left, on the right, right? In an array, at least it means on the left, on the right. So if I take 5, if I consider 5, who are my neighbors? 1 is my neighbor, 2 is my neighbor, right? So these are my neighbors. Given a child and its neighbors, if the child has a higher rating, so 5 has a higher rating than 1, right? So number of candies awarded to 5 should be greater than 1. right? If one has one candy, then the child with fifth five rating should have two candies, ideally, right? So over here also, let me make this one actually. Yeah, over here also. So if you take two, right? If you take two, your yeah. If you take consider two for five. Just talking about five, right? Five is greater than two, right? So, so the child with the rating five should have more candies than the child with rating two, right? So that's what it means. Okay. And the question is that you need to find the minimum number of candies that you can give. Let's say that you're very stingy, right? And then you have to distribute the minimum number of candies. You can distribute 100 candies, right? I can distribute 100 candies to one, right? 101 candies to five, and then still 100 candies to this thing, and then similarly, like 90 candies. I can distribute how many ever candies that I want, keeping these constraints. But the question is to minimize the number of candies that you're gonna give. Perfect, right? Now that we have understood the question, let's see how we can solve it. Okay. Let me consider a bigger example. Okay. So there's a bigger example. Okay. Let's try to solve it for this. Okay. What we're gonna do? First, let's dry run it, just with our approach, right? And then let's think about the solution. Let's think about the code later. Okay. It doesn't matter. Let's just figure out how we would do it normally. Okay. Let me create another array of size 8. Okay. Perfect. Okay. Now, what does the question say? Every child must have at least one candy, right? So what we're gonna do? We're gonna give one candy to every child, right? That should be a minimum number of candies, right? So minimum number of candies is 9, right? Minimum. No, wait. Wait. My bad. What I'm saying is the least number of candy that you can give to this particular ratings array is 9, right? The least. Okay. So 1, 1, 1, 1, 1, 1, 1, 1, 1. So I've given the least number of candies to every child. Okay. Perfect. Now let's see that. Let's go through it again and let's satisfy the second constraint. The second constraint is that given an ith child, if it has more rating than its neighbors, right, the number of candies it should have should be greater than its neighbors. Okay, perfect. Now, what we're gonna do? Let's go to 6. Okay, when I'm at 6, I see that I'm greater than 1, right? Okay, meaning that I need to have more candies than 1, right? And I'm greater than 3 too, right? Okay, I need to have more candies than them. Okay, what am I gonna do? I'm gonna make this 2. Right? I'm gonna give it 1 extra candy. Perfect. Now, I'm at 3. Okay, I'm at 3. I see that my left neighbor, which is 6, right? It's it's greater than me. Perfect. And it has 2 candies. Perfect. But if you see my right neighbor, it's less than me, right? So I need to have more candies for 3, right? But if I'm gonna make this 2, if I'm gonna make this 2, right, this condition would break. Why? Because this is supposed to have more candies than its neighbors, right? So what I'm gonna do, I'm gonna make this 3, I'm gonna make this 2. Okay? Perfect. Now, now we're done for this thing. Let's go to 3. 1. Right? 1 is less than 3 and it's less than 1. Perfect. So I'm gonna just keep it 1. Right? Let's go to 10. 10 is greater than 1. Right? It's greater than 1 but less than 12. Right? It should have more candies than 1. Right? So what we're gonna do? We're gonna make this 2. Perfect. Okay. Now 12. Right? 12. 12. If you see 12, it's greater than 10, right? But it's less than 20. It should have more candies than its neighbors, right? Children with higher rating gets more candies. Yeah, it should have more candies than its neighbors, right? I have currently one. If I make it two, it'll have equal number of candies as 10. Right? But I need to have higher, more candies, right? So what am I going to do? I'm going to make it 3. Okay? I'm going to make it 3. Perfect. Now, coming to 20. 20 is greater than 12. Okay? It's greater than 12. But, yeah, I mean, it's greater than 12. It's greater than 5 as well, right? So it has 1. It needs to have more candies than its neighbor, right? So what am I going to do? I'm going to increase it. I'm going to make it 4. I'm going to make it 4. Okay? Right. Now 5. 5 is less than 20, right? But greater than 2, right? So what am I going to do? It's greater than 2, but less than 20, right? So it needs to have more candies than 2, right? So 2 has 1. I'm going to make it 2, right? This satisfies this condition as well because 5 is less than 20, right? So 5 has 2 candies and 20 has 4 candies. Makes sense. Okay. Now, what would be the candies for 2? It should have less number of candies compared to its neighbor, right? If it has less rating, right? 2 has less rating than 5 and it has 1 candy. It's perfectly fine. Okay. Perfect. What would be our result? It'll be the cumulative result of I from 0 to n minus 1. It'll be the sum, right? It'll be the sum of the result. Yeah, fine. Perfect. This would be our answer. This would be the minimum number of candies that you'll have to distribute to satisfy every constraint that is given to you. Perfect. Okay. Now, let's take a look. Let's take a look into the constraints, right? The constraint is given to you as 2 into 10 power 4, right? 2 into 10 power 4. What does that mean, right? If I have a solution of n square, what is the most brute force way that you can do? Just how we did it, right? Just exactly how we did it, right? Which would be n square, right? So, looking at the constraints, 2 into 10 power 4 into 2 into 10 power 4, right? What would that be? Let's take it as 10 power 5, right? 10 power 5 into 10 power 5. I mean, 2 into 10 power 4, 2 into 10 power 4 ideally would return to 4 into 10 power 8, but even that would throw you a TLE, right? Uh, I mean, 4 into 10 power 8 would also throw you TLE, right? Yeah. Even if you consider it as 10 power 5, right? 10 power 10, it's still going to throw you TLE, right? Why TLE? Because you cannot process 10 power 8 instructions, 10 power 9 instructions per second, right? I mean, these servers cannot process them, right? So, and they check only for a second, and if it crosses a second, it's going to throw you a TLE, right? LeetCode does that, right? If the server, when it's checking, if the limit crosses 1 second, it's going to throw you TLE because it is not possible to evaluate 10 power 10 instructions per second. It's going to take him more than a second to do it, right? It's not that the system is slow, it's just that that is how it's built, so that we solve it with, we get to the optimized approach. Okay. Now, how else can we do it? Okay. How else can we solve this? Let's think about it. What can I do here? Okay. You know what? I'm thinking of an approach. See. The question says that you need to check your neighbors, right? Your immediate neighbors, right? That is to your left and right. Okay. Now, in one pass, right? In one pass of the array, I don't think we'll be able to. We will be able to, right? But what I'm trying to say is, if you are doing it, you'll have to make sure that, like, if you're doing it for the ith element, right? You'll have to make sure that the condition is still satisfied for the elements from 0 to y, right? By that, what I mean is, what I'm trying to say is, see, you have 3, right? For 3 is 3 is lesser than 6, right, but greater than 1, right? So ideally, initially only for these three elements, I'm talking about only 1, 6 and 3 and 1, okay, only for these four elements. Ideally I give 1 candies, right? Okay. Now now for 3, right, I mean when I'm at 6, it has to be higher than 1 and it has to be higher than 3, so I'm going to make it 2, right? Ideally I made it 2. Okay. When I'm at 3, right, see, this is where the issue is. When I'm at 3, I'm checking immediate neighbors 6 and 1, right? I'm checking 6 and 1. Okay, it has to be less than 6 but greater than 1, right? But 6 has 2, right? If I'm going to make this 2, it's going to be equal to 6, which is not correct, right? So what did I do? I had to change the value at 6 as well, right? I had to change the value at 6 as well. I had to make this 3, right? Only then make this 2. Now it makes sense, right? So what I was trying to say is, in one pass if you go, you won't be able to resolve it. I mean, you'll have to make sure to resolve it for 0 to the ith element, right? Make sure that the condition is still valid, right? Okay, that would make it very complicated, right? Not very complicated, but it's still, it really doesn't, make sense to go there. Okay, instead what we can do is, we can keep the we can keep the constraints as it is, right? And since you'll have to look at your left and your right, right, instead of going through it in one pass, let's go through it in two pass, right? But that, what I mean is, first let's go from left to right, then let's go from right to left, right, right. Let's see. Okay, first let's go from left to right, then let's go from right to left. Okay, right. Now, from left to right, when you're going, your time complexity would ideally be of O of n. Yeah. So for the right pass, your time complexity would be O of n, right? And then for the left pass, it'll be O of n. So ideally, we would achieve a time complexity of O of 2n, which is nothing but O of n, right? It's gonna be O of n. Perfect. Okay, let's get started. How are we gonna do this, right? Let me uh, take this example, right? Let me copy this. Okay. Now, you know what? Let me draw a graph type of thing. Right? Let me mark this one. Mark this one. This is 6. 6 6 3 1 10 1 10 12 20 5 and 2. 1 6 3 1, right? So 1 to 6, right? And then this thing to 3, and then this thing to 1 to 1, right? And 1 to 10, right? 10 to 12, right? 12 to 5, right? 5 to 2. Perfect. Okay, now let's see. Okay, I'm going only from the left to right on the first try. Okay, what am I going to do? Right, this has okay, should I mark it with one candy? Yeah, you know what, ideally all of these have one candies, right? All of these have one candies, right? So what am I going to do? And I'm going from left to right, right? I'll look at 6. Yeah, I'll look at 6. Okay, and oh wait, I forgot 20. Sorry. This is 20. Okay. This is also 1. Okay. Now, when I look at 6, 6 is greater than 1. Okay, I'm not looking at the right, only on the left. 6 is greater than 1. So it's supposed to have more candies, right? This is going to be 2. Okay, for 3. 3 is less than 6. Perfect. Let us keep it as 1. 1. 1 is less than 3, so we'll keep it as 1. Right? 10. 10 is greater than 1, so we're going to make it as 2. Right? Okay. Now, we have 12. 12 is greater than 10, so we're going to make it as 2. Okay. 20. 20 is greater than 12, so we're going to make it as 2. Right? 5. 5 is less than 20, so we're going to keep it the same. And 2. 2 is less than 5, we're going to keep it the same. Perfect. Okay. So currently we have 1, 2, 1, 1, 2, 2, 2, 1, and 1. Right? Okay. Perfect. Let's go from the right to left now. Okay. 2. There's no right, so let's keep it as 1. Right? 5. 5 is greater than its right. Right? 5 is greater than its right. Okay. It's greater than its right. Okay. If it's greater than its right, it's supposed to have 1 more than the right. Right? That is the idea. So currently 2 has 1. If 5 is greater than the right, it is supposed to have 1 more than the right. So 5 is supposed to have 2, but it has 1. Right? What are we going to do? We're going to make it 2. We're going to make it 2. Okay. Now 20. 20 has 2. 20 has 2. Right? 20 is supposed to have more candies than its right neighbor. Right? Right has 2. 20 has 2. Right? Now, if I want to add one more candy, 20 is going to have 3. Right? So max of 2, that is current, that is 2 comma 3 is 3. Right? So I'm going to make this 3. Okay. Perfect. Now for 12. Right? 12 is less than 20. 12 is less than 20. Okay. It has less candies than 20 as well. So we're going to leave it like that. Right? Perfect. Now 10. Right? 10 is less than 12. Right? 10 is less than 12. It's gonna have, once again, this is gonna 2 and this is gonna have 3. Right? Okay. Now 10 is less than 12. Right? And if 10 is less than 12, what is the previous answer we got? 12 3 we got. Oh wait, did I make a mistake here? Two, I made this 3. 20 had 4. Right, 20 has 4. So from the left it's greater. So ideally it had 1. Then it had 2. 20 had greater than this thing. So it's supposed to have 2. Right? Now 2, 5. Now 20 has 3. Right? 20 has 3. Okay, let's come at it again. Right? 5 is greater than 2. Right? So it's supposed to have 1 more than this thing. So it's gonna be 2. Right? What did 20 ideally have? 20 ideally had 2. 20 ideally had 2. 12 also ideally had, initially from the left pass it had 2. Now if you think about it, 20 is supposed to have greater than 5, right? Because 20 is greater than 5, right? I'm looking at the right side, right? So for 5 will be 2, for 20 will be 5, right? 20 is supposed to have greater than 5. 20 has 2 currently, right? So it's supposed to have greater than 5, which is going to be 3. Okay, I'm going to make it 3. Okay, in that case I have 12, right? 12, what ideally is less than 20, so it has 2. Okay, 12 is less than 20, so it has 2. 2. I think I'm making a mistake during the left iteration. You know what, wait, let me start again. Let me start over again. Okay, You know what? Let's do one thing. Yeah, let's not set these values. Let's carry forward from the previous values. Okay. But that what I mean is, let's do this. See, one will have a minimum one candy, right? We're going through the left iteration now. We're going from left to right, from left to right. Okay. Now, one will have one candy, right? One will have one candy. Okay. Now six. We're only looking at the left side. Six is greater than one, so we'll have one more extra candy than one. Right? It'll be two. Okay. Now three. If you look at three, 3 is lesser than 6, right? 3 is lesser than 6. Okay, so it's 3, since 3 is lesser than 6, right? We would give it one candy. Or 3 is lesser than 6, so it will have one candy. Okay, 1 is lesser than 3, right? So this will also have one candy. Right? If you look at 10, okay, I think I know where I went wrong. Okay, I went wrong in the calculation. My bad. Okay, right. Okay, now 10. 10 is supposed to have 10 is supposed to have one more extra candy than its left neighbor, right? So this will have 2. Okay, when you look at 12, 12 will have extra candy than 10 because it's greater than 10, so it'll have 3. Similarly, 20 will have 4, right? 5. 5 is lesser than 20, so it'll have 1, right? 2. 2 is lesser than 5, so it'll have 1, right? Perfect. This is correct. So our left iteration is done. Okay. Now let's go from right to left. Let's go from right to left. Right? Let's go this way. 2. 2 is, I mean, there's no right neighbor to compare it with, so it'll be 1. Right? 5. 5 is greater than 2. 5 is greater than 2. So it's supposed to have one more extra candy than 2 has. 2 currently has 1, right? And 5 has 1. It's supposed to have one more extra candy, right? So extra candy that I need is 2. Current candy that I have is 1. The maximum is 2. I'm going to pick 2. Okay. Why 2? Listen to this carefully. 5 has 1 candy. 2 has 1 candy. 5, I'm looking at the right neighbor now. 5 is greater than 2. Meaning that 5 is supposed to have 1 extra candy than 2. Right? But 5 has just 1 candy. Right? To make it an extra candy, we'll add 1. Right? So now 5 has 2, 2 has 1. Right? That is why I'm taking maximum of extra candies that I need, right? Plus, I compared it with the current candies that I have. Current candy that 5 has is 1, right? To make it more than 2, I need 2 candies. So max of that is 2. Okay. Now 20 and 5, right? Okay. I have 20 has 4 and 5 has 2. It's good enough, right? I don't have to compare it. Okay. Perfect. Now 12. 12 is less than 20, right? 12 is less than 20. Okay, and it has less candy than 20. Perfect. I don't have to do anything, right? 10. 10 is less than 12 and it has lesser candies compared to 12. Perfect. I don't have to do anything. 1. 1 is lesser than 10 and it has candies lesser than 10. Perfect. I don't have to do anything. 3. 3 is greater than 1, right? 3 is greater than 1. So 3 needs one more candy to be greater than 1, right? So number of candies of 1. Number of candies of 1 plus 1 would give the number of candies that 3 has, right? So 3 has 1, 1 has 1, right? So I need one more extra candy, right? So this is gonna be 2. Okay, perfect. Now 6. 6 is greater than 3, right? 6 is greater than 3, right? So it needs to have more candies than 3, right? So but it has 2. One more extra candy would make it greater, right? So this would be 3. This would ideally be 3, right? And this is 1. 1 is less than 6, so perfect. It's perfect. So this is our final answer. Let's compare it with the old one, right? 1 3 2 1 2 3 4 2 1. 1 3 2 1 2 3 4 2 1. Perfect. So we got our answer, right? What are we doing, right? We're first going from left to right, which is O of n, then going from right to left, which is also O of n, right? Ideally, the time complexity is O of n, right? Right, perfect. What is the space complexity? Right. It depends on you, right? I would want to store the result, right? So I will create an array of size n, right? So space complexity also would be O of n, but you can figure out some way with carry forward, as in like with the previous value, you can just carry it forward and add +1, or just keep it like that. It's up to you. That will reduce the time complexity from O of n to O of 1, right? That is an optimization that you would want to do if you want to do it, or it's okay to, right? Okay, perfect. Now that we understood the solution, let's get into the coding part. Okay, so what am I going to do? Okay, I'm going to create an array. This is going to have the same size as the ratings, right? Ratings dot length. Okay, perfect. Now, I'll just fill array of 0 with 1, right? Array of ratings dot length -1 also with 1. Okay, now let me go from left to right, right? That is the first thing, right? Left to right. Okay, now when we're going from left to right, what I'll do is for int I equals to 1, I less than, I would ideally go till n minus 1, right? You know what, I'll just take this, and then ratings dot length -1. Okay, so I would ideally go till n. Okay, wait, n minus 1. Okay, you know what, will it go till n, right? Yeah, I'll go till n, right? And then I plus plus. Okay, so what am I going to do? If ratings of I is greater than ratings of I minus 1, right? Ratings of I is greater than ratings of I minus 1, right? So if ratings of I is greater than ratings of I minus 1, right? Let's come back to this. So 6 was greater than 1, right? I need one more candy than 1, right? So what am I going to do? I'm just simply going to do array of I equals to plus equals to equals to array of I minus 1 plus 1. Done. Okay, now what do? We just form this left to right part, right? We just form this left to right part, right? We went like that. Done. Now that is done. Now let's go from right to left. Let's go this way. Okay, let's go this way. Yep. So over here, what am I going to do? I'm going to iterate again from for int I equals to n minus 2, right? I greater than equal to 0, right? I greater than equal to 0, and I minus. Okay, what am I going to do here is that I'm going to compare, right? I'm going to compare if ratings of I is greater than ratings of I plus 1, right? Now in that case, what I'm going to do, I'm going to check, I'll have to check if array of I, if array of I is less than array of I plus 1, then in that case I have to change. By that what I mean is, for example, when we came to this 3, when we came to the 6, initially it was 2. Initially it was 2, right? And this 3 also had 2, right? But 6 is, since we're going from right to left, right? So 6 is greater than this 3, right? But array of 6, it's 2. Array of 3 is also 2, right? So array of 6 is not greater than array of 2. Sorry, wait, I think I'm just confusing you. So we have 6, we have the number 6, right? And then we have the number 3, right? Initially when we were iterating, right, this was 2 and this was 1, right? Now what I'm trying to say is, what I'm trying to say is that, right, when I was going from this direction, this became 2. We made it 2 because it has to be greater than 1, right? Now since we made it 2, this 6 is greater than 3, ratings of I is greater than ratings of I plus 1, but array of I, which is 2, right, it's still the same as array of I plus 1, right? It should not be. If it's same or if it's less, what do I have to do? I'll have to increase it, right? So what am I going to do? I'm going to increase it. Less than, I'm going to make array of I equals to array of I plus 1, right, plus 1. Okay, done. I think we made a small mistake over here. If ratings of I is greater than, see, we can't have it as 0, right? Array of I can just keep it as 1, right? Okay, now what we can do, we can just keep int answer equals to 0, right? And then we can just do for int val in our array, right? And then answer plus equals to val. Yes, ideally this should return us the answer, right? Okay, let's see. So what am I doing here? I found the candy that I have to give it to each child. I'm just summing it up and then returning the final answer. Okay, let's see. Okay, I got a compilation error. Ratings. Okay, ratings. Okay, I got a wrong answer for the first one. Expected as 5. For the second one, I got the right answer. Okay. Let's see where we're going wrong. Right, for int val in array, right? System dot out dot. Okay. Let's see. Where are we going now? Okay, we have 1 2 2. We got 1 2 2. Okay, we got 1 2 2. You know what, let's look at it for our example itself, right? Which was ideally 163110.12. 1631 1631 10 12 25. Okay, what did I get? 1 2 2 1. Okay, for 10 I got 1. If ratings of I is greater than ratings of I minus 1, this value seems to be correct, right? This value seems to be correct. Okay, you know what? Let me check this. The left to right seems to be correct, right? Let me check right to left. Okay. I think this is where I'm going wrong. Okay, let's see. Okay. This is where I'm going wrong. Because if you see, the answer is supposed to be in the end 4-1, but it's 4-1-1, right? Why? Probably because ratings of I is greater than ratings of I minus I plus 1. That is correct. Maybe this if condition is wrong. Okay, see, ideally, what does it have to be? See, if array of I, that is the candy that I already has, if it's greater than the previous one, then we don't have to do anything, right? Now, uh, see, for example, you have 5, you have 20, right? 5 initially had 1 and it became 2 when compared with 1 when I'm going from right to left. Then coming to 4. Now, 20 already has 4. If I do 5, the candies that 5 has, that is 2. If I do 2 plus 1, 3. It's still less than 4, right? It still satisfies the condition even if I don't do plus 1, right? So I can check the max that the array of I has and the array of I plus 1 can offer. But that what I mean is I can check the max that I has, which is 4, right? And I can compare it. I can compare it with the one that 5 has plus 1. 5 has 2, right? 5 has 2, right? Plus 1 is 3. 4 is still greater. 4 is still greater, right? 4 is still greater. So I don't have to increment it. I can just go forward, right? Makes sense. Let me say it again. 20 is greater than 5, right? Okay. So rating is greater than rating of 20th, rating of child with 20 is greater than rating of child with 5, right? So now we have entered the condition where we have to give more candies to 20, right? Now, if 20 already has a greater candy, then we don't have to care about it, right? If 20 already has a greater candy, then we don't have to care about it, right? So what are we going to do? So if 5, the number of candy that 5 has plus 1, which is 3, if it's still less than the number of candy that 20 already has, then we don't have to do anything, right? Because it satisfies our condition, okay? So we'll just move forward, okay? So what I'm going to do is, this one, I'm going to remove it. I'm just going to set it as array. Maybe this will work. Let's see. Math.max of array of I plus 1 plus 1, right? I'm going to give plus 1 compared with array of I. Right? So this is going to set the value simply. Right? Let me run it. Hopefully this should work. Yes. Okay, this worked. Okay. Now let me submit this. Perfect. Okay. We got a runtime of 3 ms and yeah, it should ideally be open, right? Perfect. Okay. I really hope you understood the solution. I know the video was long, but that was the whole point of this, right? And I would suggest you try run the same problem again and then do it on your own, right? So that you understand the concept behind it. It's not about solving the problem, it's understanding how the problem is working, right? Yeah, I hope you understood. I hope you enjoy this video. Yeah, I'll see you in the next one. Thank you.